There we go. So our next presenter is Debbie Yuster from Ramapo College of New Jersey. And Debbie's going to talk about infusing reproducibility into introductory data science. So thank you very much.
Okay, thank you, Rohan, and all the organizers for having me here. Just get everything set up. So I think that my talk is sort of at the other end of the spectrum from Joelle's, right? She was speaking about reproducibility at the highest echelons of professional researchers. And I'm going to be speaking about reproducibility for beginning students who are just starting to learn about data science. So it's really kind of the other extreme, and I won't be offended if the professional researchers don't want to stick around for the Data 101 talk, but that's what I'm here to speak about. Let me give an acknowledgement first. My entire curriculum for this course and all the practices of reproducibility and nearly everything I've done in the course has come from Mina Chetinkaya-Rundell and her Data Science in a Box curriculum. If you're not familiar with Mina, she's at Duke University, and she also works for RStudio Education. She's extremely active in statistics education and specifically with R. So everything comes from her curriculum. Okay, so if you haven't heard of Ramapo College, it's a small public college in northern New Jersey in the New York area, about 6,000 students. And Ramapo only 2 years ago launched a data science department and program, both an undergraduate bachelor's degree and a small master's program. So I came to Ramapo at this launch. They had a group of hires. Previously, I had been at SUNY Maritime College. My background is mathematics, so I've actually been transitioning from math into data science. So I came to Ramapo just as their data science program was launching, and I've been the sort of inaugural instructor for this Data 101 course. So Data 101 is our introductory course. It's the first required course for data science majors, and there are really no prerequisites. So I know at a lot of colleges, students coming in for data science, they have some statistics or some coding. In my case, some of the students do, but it's not required. So we have a pretty broad range. We have everyone from senior computer science majors down to freshmen who have never seen a line of code or learned any statistics beyond the Common Core in high school. It's a small class, about 25 to 30 students. And the textbooks we use are Wickham and Grolemann's R for Data Science and Intro to Modern Statistics. That's a book in the Open Intro Statistics series. This one used to be called Intro to Statistics with Randomization and Simulation. It's evolved into Intro to Modern Statistics. These are both open source textbooks freely available. I mentioned the Data Science in a Box curriculum already, and we do everything in RStudio and using GitHub. So all my little logos there. So we really have two aspects of reproducibility in the course. The first one is that everything that we do is done in R Markdown. So I assume most people are familiar with it, but for anyone who's not, an R Markdown document is a piece of code, and it contains, you import the data, you do your analysis, you generate figures, you have narrative, and then you can compile it into all different formats. So similar to if you're writing a report in LaTeX, you have the source code, you compile it to the PDF or to whatever you're building, Beamer presentation. It's pretty analogous, except that in our Markdown, it's not just the results, the analysis is taking place when you compile that document. So we talk with the students about reproducibility, that anybody who wanted to understand how you got the results you did can simply go through your code and see any steps that you took to process the data, what you've done in your analysis, the choices that you've made along the way. All of that is transparent if you are willing to share your source code with them. And nobody has to take your word for it when you say the results. All they have to do is knit your document. They have to agree with how you've set everything up, but they can verify it for themselves. We also talk about GitHub for reproducibility. for both version control and for collaboration. Okay, so if you're coming here as the professional researcher, this all sounds very basic and elementary, but you can imagine as a college freshman, and sometimes I've had students who are at social work majors or all kinds of different majors coming to just check out what is data science. So this can feel like a lot. It's important to not knock them with it all on the first day, but to sort of build it up slowly. So what does that look like for the R Markdown? On the first day, we start with a fully formed R Markdown report. So what I did this year was an analysis of COVID data from different countries, and everything is already set. They have that code to start with, and first they start simply knitting it. That's already not so easy. They have to learn the layout of RStudio, but they knit it. And then we go in the code and we see where the countries were selected, the countries that are displayed in the graph. I'll show you later. And they just simply make a change. Maybe statistics from the US are there. Maybe they change it to Poland, whatever they want. So they make some change in the code and they reknit. So that's just how we start. And then little by little, the scaffolding starts kind of dropping off, where maybe the next week I provide them with a piece of template code. It has the YAML, that's the kind of header information. I've already loaded the data set and the packages they'll need. And I've given them headings, and question 1, question 2, and they just have to fill their code in. And as the semester goes on, they start having less and less. In the end, it's maybe just a blank document, just that kind of header stuff, and they have to do the rest on their own. It's also important, I find, to give a lot of tips along the way. Of course, when students start out, so they want to kind of write their whole report, and then they click knit and they find that there's a knitting error. The code is not compiling, and they have no idea what to do. They don't know where the problem is. There's some very esoteric error message that's not making any sense to them. So just again, things that are obvious once you have experience are not obvious to people who've never done this before. So you have to really emphasize to students, knit very often. This way you can isolate where the problem is. If your document doesn't compile, so don't delete everything that you had, comment out certain sections, get it to a sort of minimal working example. And from there, try to isolate where the issue is and deal with it. Also, just kind of quirks of R Markdown. You have to leave a lot of blank lines in between chunks, otherwise things don't compile as intended. These are things that people have to tell you. And some of them kind of don't make any sense at all if you're typesetting an equation with LaTeX in your document. So there, you don't want to have space inside the dollar signs, or it will not compile properly. So all these little quirks that are just important to remember that it, they don't. Okay, so then for GitHub, we really build up slowly. I'll just speak about the first couple labs and how I sort of get students ramped up to collaboration through GitHub. So that very first class, the students do simple things like registering for GitHub. They join RStudio. So we use RStudio Cloud, which is a cloud-based interface for RStudio. And what's nice about it is students can then access it from anywhere they have a web browser. And it doesn't matter if you're remote that day, you're in person. We can also create something called a course workspace, which allows me to create a project that students can just click to sort of clone into their own RStudio account. And I can also peek into any of their projects through this course workspace. So they do the activity that I was speaking about, where they modify a document and reknit. So these are just some kind of clips from the lab instructions. Selecting a GitHub username, we tell them, choose something you won't be embarrassed about. These are college freshmen. They're not thinking that one day they're going to apply for a job or for graduate school, and they don't want to necessarily be like, Smushy Face 25 or something like that. They should pick a reasonable name. Getting onto the workspace, just all this onboarding stuff. And then finally, they get to start this assignment, which was, again, a COVID visualization. And we give very clear step-by-step instructions. Both times that I've taught this course, it's been on Zoom. So this format actually, it's worked well as a remote format. Here, you can't read any of this, but on the left side, we have the R Markdown code. And then here on the right, there's the rendered document. And so we have the students look through this piece of code. They don't understand any of it at this point, but they can just find where the countries are. Sorry if you can't see this. It says China, France, United Kingdom, US, and Turkey. Those are the countries that are plotted on the right. And we simply have students modify that by choosing a different country. And further down in the code, there's a list of all the available countries that they can use. Okay, so that's kind of the first week. The second week is when we actually start using GitHub. So the first week, they only registered for it. The second week, we have to configure personal access tokens. This was a new thing this year because, as you probably know, GitHub stopped allowing password authentication. And there are a number of different ways to authenticate through RStudio, but actually, if you're using RStudio Cloud, the SSH keys do not persist across projects. You have to configure it for every project. So for our purposes, because each week we're making a new project, so we had to talk about personal access tokens. It's not like a really great way to start the semester, but okay, we did it. So we got that set up. We practiced actually cloning and doing just commit and pushing. So here, just a few, again, snips from the lab. So learning how to clone a repo. And here they're doing this individually. Eventually we got to group projects, configuring the personal access tokens, and just talking about using GitHub through RStudio. There's a nice integration there. And that's how we used GitHub. Okay, so after that first week, they're used to having their own individual repo, working individually and pushing their commits. The following week, I break them up into groups. So the groups are in breakout rooms, but each student is still working on an individual repo. This is just kind of getting them ramped up to their group work. And I'm still cueing them when they ought to commit and push. Eventually, this is something they'll just sort of get a feel for themselves. I remind them all of the instructions because it's still fresh, you know, how to clone, how to use GitHub. And at first I give them these very detailed cues, you know, write a commit message that says completed exercise 1. But eventually it's just a sort of cue that says, now's a good time, write an appropriate message, commit and push. So now they've worked in groups on their individual repos. The following week, they actually have a team repository. And so this is a little trickier, as you can imagine. They have to sort of coordinate who does what, and hopefully not get into any merge conflicts just yet. So this week is a little dicey. But they have their team repos, and I'll talk a little bit later about how, oh, sorry, I missed the chat window. Let me just catch up on chat. I'll talk in a second about how I create all these repos. Oh, Rohan, the PATs. Yeah, the paths were really bad. I'm just responding to Rohan's comment about the paths. Yeah, it was not clear when GitHub made its change that you could not use SSH keys with RStudio Cloud. I don't know. According to Google, I'm like the first person who realized that and documented it. So yes, that was very painful. Oh, so Colin's using SSH keys. I think, Colin, you must be using the server version. RStudio Workbench supports persistent SSH keys across projects, but RStudio Cloud does not. So that was the problem, is all the people I chat with about this stuff are all using Workbench, which is where you have a local server at your school. So I was running into trouble and didn't understand why it was working fine for everyone else. It turns out it works on Workbench. It doesn't work on Cloud. Okay, so anyway, for lab 3, this is the first group assignment. I have a very tightly coordinated dance that says, you know, team member 1, answer this question, push your code, and everyone has to practice then pulling. So the new thing here really is pulling and sort of learning to wait your turn. And then finally in lab 4, we actually induce merge conflicts, which I've been really hoping until this point we don't encounter. Now we sort of, it's kind of, if you've ever taken a kid for an ice skating lesson, the first thing they tell the kids is, okay, everybody fall down, right? Because they don't want the kids to try ice skating while being afraid to fall. So they say, just fall down, you'll see it's not so bad, you'll get up, and then you won't be afraid. So that's what we do in week 4 is we say, everybody's gonna get into a merge conflict and let's learn how to get out of that. So we have this very choreographed induced merge conflict where we have, member 1 push a change, member 2 does something conflicting, and they have to get out of it, and they learn, what a merge conflict looks like and how to take care of it. And after that, that's basically it as far as getting them ramped up to using GitHub. So I keep it very simple in my course. This slide is not prescriptive instructions. This is just what I do. I use a very small subset of Git functionality to keep it manageable for beginning students. There's already a lot on their plate without having to worry about the more advanced Git stuff. So we don't do anything on the command line with Git. It's all through the RStudio integration. We don't do branches. I don't even do issues. We could, but we keep it very simple. They're pushing and pulling. That's about it. Okay, so one of the tough parts I found is getting buy-in from students, because to students, this all seems like a giant hassle. Some of them get really interested in doing it and learning more, and some of them I found, I go to visit the breakout room and they say, oh, we had a merge conflict, so I just deleted that project and I just recloned the project. Or, oh, I just did all my work in Notepad and then I pasted it in at the end. So it's tough to sort of get students on board and convince them to do all this, in addition to the actual data science content that they're learning. So I talked to them about the inherent value of reproducibility, all the things that you guys know and that we're here to talk about at this conference. It doesn't really resonate with college freshmen. So those of you with experience can see what goes wrong when work is not reproducible. But to someone just starting out and you tell them, oh, well, if you use Excel, people can follow your steps, maybe you did something wrong, it's not that compelling to them. Same thing with collaboration, which is one of the main reasons that we're using GitHub, is to allow students to work in groups. If you're someone who's coming from the days of emailing versions back and forth, so you really appreciate GitHub. But if you're a college freshman, that's not where you're coming from. You're coming from a world of Google Docs. And to tell students who are used to Google Docs, oh, look, it's so easy. You just have to push your work and then everyone pulls your changes. That I found that most of them are not buying it. The sort of sales pitch that resonates a bit more, if you tell students, listen, GitHub is an industry standard tool. This is what all the pros use, the professional researchers, the professional developers, and data scientists. So then, okay, they like for things to be relevant, and this is something they'll continue using. So that definitely helps. And the most sort of effective sales pitch that I found is telling them, hey, if you apply for your internship and you've used GitHub and the other person hasn't, they're going to be very impressed. And not only that, but when it's time to apply for grad school or jobs, you put a link to your GitHub page and they can see the work that you've done. And this is a really wonderful thing. That's the reason that sort of resonates the most. And I think that's fine. I don't think that we have to have new students really believe that the value of reproducibility is paramount. I think if they're doing it because they want to get a job, I don't think there's any shame in that. Okay, let's see. I know we're a little behind, so let me just quickly mention the course infrastructure. So like I said, we use this RStudio Cloud plan. It's unlimited, so I don't have to worry about project hours, or if somebody needs to ramp up the RAM if we're doing web scraping, it's fine. I have a GitHub organization for the course, which is free for education. So I have just tons of repos in there because every lab has a repo for every either student or team. The assignment instructions, I did not create like a big distill website. I use the LMS, but within the LMS, I have individual pages for the assignment instructions, and those are just created by knitting the R Markdown document into HTML, and then I push it to my GitHub repo, and I have GitHub pages activated. To create and distribute the repos, there's a very helpful package. Thank you, Colin, who's on here, GH class. It's really just interfacing with the GitHub Classroom API, but it's really nice. I can do everything from within R, create and push the assignments. And I should mention these are private repos. I know at this point, I guess everybody can make private repos, but when I started, you had to be on an elevated account. So with the educator access, each student's assignment is in a private repo. I don't have to worry that they're snooping on each other's work, at least not through GitHub. And then for just submission logistics, the students download their PDF reports and they submit those to Gradescope, which is where I do my grading. Okay, so if you want more information about any of this, obviously you can email me. I highly recommend checking out Data Science in a Box. All the course materials are there, along with a lot of information. There's a link to the Slack group. Everybody's very friendly on the Slack and will answer any questions. There's some really great recorded workshops online by Mina and Colin about teaching R online, using RStudio Cloud in class, and also teaching computing with Git and GitHub. If you're interested in integration between RStudio and Git, you should check out this book by Jenny Bryan, which is online, Happy Git for the user. GitHub Education is where you can get training for you, your students, and the access. And I also just linked to the RStudio Cloud subscriptions in case anyone's interested in pricing info. Okay, that's all I have. Thank you.
Thanks very much, Debbie. Does anyone have any questions or comments for Debbie? I'll just start off maybe while folks, they can just raise a hand and I'll call them. But so with RStudio Cloud, who pays for that in your setup? Does the department pay?
Yeah, so in my case, there was no option for students to pay directly. Now I believe they've just added it. So my department paid, but we charge students a lab fee. So they kind of took it out of the lab fee. It comes out to about $20 per student per semester. So it's not that much. Now that there's a direct pay, we would probably go with that, especially since I'm using free textbooks. So it's not a tremendous course expense to ask students to carry.
Does anyone else have any other questions or comments? Devin, is there a talk?
Talk that could be
sorry,
used to
right.
sell
That's probably
GitHub.
more for me. Devin, I'll look at this. I'll look at this one later. Yeah. Sorry. Are there any other questions or comments? What's the sizes of the classrooms that Sorry, that you were teaching?
About 25 to 30 students. I don't have TAs, so it has to be small enough that I can manage it and go around, actually get around to each of the groups and all of that. So it's a small class.
And so you have these labs going throughout, and these are for credit. And then at the end, is there a project, or how does that work?
Yeah, we do a final project. So the way it worked is it's a 4-credit class, and about roughly, I call it half lecture and half lab is how I had it set up. So there are some also exams, which I was doing as take home during the pandemic. I'll probably switch to synchronous to in-person once we're back. And there's a final project done as a team where they basically pick a data set on any topic they want, and they do a whole analysis, some exploratory analysis, some modeling. They give a report and presentation at the end.
Robert's just clarifying the timing.
So it's 200 minutes a week. So the way that I had it split up, because it was in the fall, it was still virtual. So I did it half asynchronous. The lectures were all recorded and students watched it. And then we met synchronously for 100 minutes. And that was the lab period. So it would be nice to have more time, but it doesn't always work out.
If they're applying to University of Toronto, send your strong students to apply for grad school at University of Toronto, and GitHub pages certainly make a huge impact when I look at applications.
Yeah, I'm going to tell them you said that.
It's just easier to stand out, right? Because so few people do that. And so if you do it, then it's like, oh, I don't know this person, but they can prove that can do all of this stuff. So it's just so much easier.
Yeah, and the learning curve is tough, but once they get past it, so now they're just used to these tools, and reproducibility just becomes the norm for them. So it's a nice way to start students off.
Thank you so much for your talk, Debbie. Really appreciate it.
Thanks for having me.